Imagine a world without a sun. A lonely wanderer drifting through the eternal night of the interstellar void, far from any star's warmth. These are rogue planets, celestial orphans that have been cast out from their home solar systems to roam the galaxy in isolation. Recent discoveries by NASA and the ESA are changing everything we knew about these free seekers and their potential to harbor life. But how does a planet become a rogue? It usually begins with a chaotic dance in a young, crowded solar system. Gravitational tug-of-wars between massive planets can launch smaller worlds out into the dark, severing their connection to their parent star forever. Unlike our orderly solar system, the interstellar void is a chaotic frontier where billions of these planets sail through the dark. When we look at the Milky Way, we see stars. But the space between them is far more crowded than we ever imagined. Current estimates suggest there could be 21 rogue planets for every single star in our galaxy. That is trillions of hidden worlds. The sheer scale of this invisible population means that rogue planets might be the most common type of planet in the universe. However, life as we know it requires energy. On Earth, we rely on the sun's radiation to keep our planet warm and thriving. A rogue planet's moon faces a grim reality: zero sunlight, a frozen surface, and an atmosphere that would likely collapse into ice. So how could life possibly survive in such a desolate place? The answer lies in a phenomenon called tidal heating. Just like Jupiter's moon Europa, a moon orbiting a massive rogue planet can be stretched and compressed by intense gravitational forces. This tidal flexing creates immense frictional heat in the moon's core. It's an internal furnace that doesn't need a sun to function. This heat can melt subsurface ice, creating vast liquid oceans that remain hidden beneath a protective frozen crust for eons. In these dark oceans, geothermal vents could provide the chemical energy needed for life to begin and evolve in total darkness. But tidal heating isn't the only solution. Some rogue planets might possess a secret weapon for warmth: hydrogen. A thick atmosphere of hydrogen can act as a powerful insulating blanket, trapping the planet's internal heat with incredible efficiency. This insulation could allow for wet-dry cycles on the surface, which are essential for forming the complex molecules of life. Even more surprising is where these planets choose to live. They often drift in the safest parts of our galaxy. The galactic center is a death zone, filled with dangerous radiation from supernovae and the massive black hole at its heart. Rogue planets drift through the quiet outer arms, far away from these disasters. They are like lonely islands in a calm sea. The hunt for these worlds is just beginning. Tools like the James Webb Space Telescope are already scanning the dark for their signatures. Soon, the Nancy Grace Roman Space Telescope will join the search, using gravitational microlensing to find thousands of new rogue worlds. We are on the verge of discovering that the universe is far more hospitable than we ever dreamed, even in the coldest depths of space. The darkness isn't empty. It's full of possibilities, waiting for us to shine a light on the life hiding in the shadows. Where do you think we will find life first? On a sunlit planet like our own, or a hidden moon in the void? Thanks for exploring the deep void with us. Subscribe to stay updated on the latest discoveries from across the cosmos.